introduce this. Okay, good evening. Thank you, Mark, and thanks for the tent that you organised for me. It's been good. Not to mention setting me up. So it's a great opportunity to be here. So it is actually a big thank you for making it possible, quite apart from the beautiful weather yesterday, which I had poking around Cape Town, which was nice. So this title, you might notice, is just slightly different to the one in your programme, but in essence they're two angles on the same thing. I want to talk about some of the framing concepts that I think constrain us in adaptation decision making. And I guess I was starting off thinking about a slide just to give you an idea of where I was going. And I was at a conference just recently for the Australia and New Zealand Institute of Environment, and they, which is basically a set of consultants particularly, and they called it this, which I thought was a really good title actually. Then Bruce Hewitson pinched these words, or quite a few of them, earlier on today, so which is actually a bit of an echo, because I think a few of the things I'm talking about have been touched on during the day for the people who have been at the conference today. But that's fine, because I still want to try and cover them. So adapt, innovate, but in order to do that, there's this issue of advocacy and having the right sort of words with which to do that advocacy in terms of how we deliver and in fact do the right sort of science. Because if there's one thing we know, and this was what Bruce said, business as usual isn't really an option. Now, for those who were at the conference today, I was going to put that up to start with, but in fact I thought I'd better spend a moment framing where my thoughts here are in relation to the sorts of thoughts that various other people have presented today. So this won't mean quite so much to the people who weren't there, but bear with me just for a minute, because I think if I don't, I run the risk of some nasty questions at the end. So at the start of today, Karen O'Brien made a brilliant talk really about the issues of substantially reframing just what we're thinking about in terms of adaptation, but at a higher level, I think, than I'm going to be talking about mostly today. So she really was talking at a level of whether, in fact, the biggest adaptation we could do on this planet, of course, is to mitigate properly, and the sorts of dramatic changes in the way we think about things that's needed for that. So that, in a sense, is about this question of do we adapt or do we mitigate? And I put adapt in inverted commas there because in fact, mitigating itself would be a sensible adaptation on behalf of our survival on the planet. But if you sit within the sort of broad area of adapting, then there's some other sort of continua you can think about. You can think about adapting just to small amounts of change or to very big amounts of change. And even thinking the bigger amounts of change, you can be stuck in a relatively short-term time frame of thinking about that, or a longer-term one. And I just wanted to put this up to say that I think my talk today is aimed mostly at assuming that you are talking on the adaptation, climate adaptation side, then what are the issues about framing it? Of course, I think that if you do that well, you are in fact making part of the case for mitigation, because as you think about some of these longer term things and the real significant challenges in those, as I will touch on, they are a large part of the case for mitigation. But in the end, I think we have to risk hedge a bit against, we can't just say, well, we ought to reframe it all and get mitigation to happen, because we've been trying to do that for the last couple of decades rather unsuccessfully. The other thing I'll just say as a caveat at the start is there's going to be a bit of an Australian focus in this. That's an apologia in case anything I say is not relevant to South Africa, but hopefully some of it will be. So let me start by, I want to sort of do a bit of the Hollywood movie thing of making you feel really bad and then try and improve things a bit. Because we've seen this today, well, we've seen something like this today, the IPCC, this comes from the previous assessment report, the sort of range of possible futures that we face. And I think, if you look back to that one in 2007, there was a possibility of anything from 1 to 6 degrees or so of warming. If you come to the latest one, which Mark New did show earlier on today, you've still got the same sort of things, like marginal changes in exactly what's going on there, but really not much. The thing that has changed dramatically, I think, in the last 5 years is our understanding of how likely we are to take different ones of those pathways. So this is some results from the Global Carbon Project, which were just released last week, and they're the latest carbon budget for the globe. And on there you can see the main coloured lines are the 4 so-called representative concentration pathways, the 4 major scenarios that are being pursued, which are being looked at in the current IPCC round. And the black line you can see dotting its way along on the left-hand side there, of course, is the actual data, because we have quite a lot more years of real data since 2007 now. And it is quite clear that our emissions, which is what's up the y-axis, are tracking firmly along the very uppermost, in fact slightly above the highest of these scenarios that we're actually looking at in the IPCC. So if there has been, and what's become apparent in thinking about this over the last few years, is the science community, I think, has become much more understanding of the fact that we can basically put 1 trillion tonnes of carbon into the atmosphere, and we're already well over halfway there. We can put 1 trillion tonnes of carbon into the atmosphere if we want to stay below 2 degrees C or have a reasonable chance of it. We can't do more than that, and we're already well over half the way there. So the likelihood of us staying below 2 degrees really has to be said to be becoming quite low. Now, this has got pretty significant implications for adaptation. So this is a plot for Australia, but I think you could probably plot something similar for many countries of the world. Again, from the previous assessment, and what it shows, just to spend a moment explaining it, is across the top there you can see perhaps different numbers. They're the different degrees of global warming, going from 0 up to about 6 or 7. And as you go across there for different sectors, there's an estimate of when we cease being able to easily deal with it. We get into a sort of coping range where you can cope, but it's definitely causing some trouble. And then you get into those reds where we're really beyond that sort of coping range. And what's pretty immediately apparent from that is there's at 2 degrees C of warming, well, there's 2 or 3 sectors that are pushing into the red. By the time you get to 4 degrees C, though, we are seriously talking about almost every single sector being into that red area. So we're not. So the 4 degrees C challenge is really a qualitatively different level of challenge in terms of impacts and vulnerabilities and consequent adaptation needs. So that's one aspect, and we really do face potentially massive amounts of change. Someone was making this point today that we actually have to recognise, I think it was Bruce, that we are going to face significant potential losses. This is an environmental impact assessment in Australia of the impacts of climate change on a measure which is basically a measure of how different future environments in particular locations are going to be to those environments today, or in fact environments anywhere on the continent today, in terms of measures which I won't go into, which are really biologically meaningful. So it's really saying those purple areas or the green areas are ones where we'll still have places on the continent which look much the same, but you can see there's big swathes of our inland where actually the sort of environment we're expecting in 2070 here under a medium projection, there are no analogues on the continent today. So some of the species, of course, will survive and move, but we're not going to see landscapes that look anything like, or communities that look anything like what we do today. And that's under a medium sort of scenario. Under the extreme one that we're currently tracking, you can see that the whole continent basically goes purple. So these are dramatic changes. And the degree of change, I warned you, I'm just really working you into a lather here, I hope. And the degree of change is just one of the problems. The other problem is for longer-lived decisions, things that we're doing today which are going to matter out to the latter part of the century. We have this great uncertainty, which I would say is definitely a social uncertainty in what our politicians and our whole society, including us, is going to do. Because the further you get into the future, of course, the more divergence you get between the very optimistic and hopeful possibility that we might recover the climate, as opposed to the track we seem to be on at the moment in a sort of runaway way. So all of that basically is pretty depressing. Actually, it's more than that. I think it is fundamentally disempowering. And so I've just done, quite deliberately, what we mostly do when we deliver the climate change message to the general public, to our politicians, to our decision makers in all sorts of other areas, presenting a picture which is, I think, essentially, as it says there, disempowering, complex, all-encompassing. Every bloody decision you make is going to be affected by it. It's fundamentally driven as a problem. It's uncertain, and it's also quite distant. So it's not surprising that people tend to switch off from that. And the rest of my talk will try and be slightly more positive, because it's really about how we think about reframing these things in ways which people have talked a bit about today as well, quite a few of these things, but I'm trying to put them together in a hopefully a reasonably solid block to say, how can we reframe these to actually encourage adaptation to get going? Because, in fact, if you look around the world, most studies show that although there's a great deal of adaptation planning going on in places, in terms of real significant investments in things that need to be invested in, there's not a great deal of sign of it. When you look at things like the reports from the Adaptation Subcommittee in the UK, where they've gone and studied whether risks that ought to be going down are actually going in that direction, such as whether the number of people building on floodplains is going up or down, it's still going up in terms of that sort of thing. So we don't seem to be tackling these sorts of issues very well. So these are the things I'm going to tackle. I'll just put them up to say that's where I'm going through the talk. But let me start picking them apart a bit and try to argue how they actually do provide a much more systematic and manageable sort of approach to this for people's minds. So the first issue is about being solutions-oriented. This is my little favourite solutions-oriented picture, but this is actually a really important issue, I think, which in fact, again, much of the stuff that we present fails to be oriented towards solutions. So I'm going to really take a go at this particular diagram, and in fact a whole variety of variants on this, which are about impact and vulnerability assessment, including adaptive capacity assessment. I happen to think there's a few quite deep philosophical problems with this diagram, but the main problem with it is it's absolutely focused on the problem. It's absolutely focused on saying how vulnerable you are. Now, you might say that's the first step in understanding things, and yes, that's true, but we do have a real tendency as a science community just to keep iterating around making this a bit more close and a bit more detail and a bit more information in there. It's not that this isn't an important thing to do, but it really needs to be a small part of a much bigger picture. And we've seen that, we've had that picture around for a long time. In fact, most of what I'm talking about today we've had around for a long time. It's a matter of hopefully pulling it together. So there's a variety of more decision-centred approaches or solution-centred approaches out there, and anyone who's done any adaptive management knows there's a million variants on this. Here's one that's been around for a good decade or more from the UK Climate Impacts Programme, which really puts the decision-making at the centre of the picture rather than the problem. I should say, just for a moment, that there's a good reason in the past why the IPCC sort of framing has tended to focus on the problem, because of course what we're trying to do is to show that the problem's bad enough that we should mitigate rather than adapt. But if we are thinking about how we motivate adaptation, we have to move to this more decision-oriented thing. And the point is not that understanding impacts and vulnerability and so on is irrelevant, of course it's not, but it should be seen as a small part of an iterative process where you don't get fixated on just getting another 3 decimal points on the impacts when there are a whole lot of other issues in the decision-making frame that matters much more. One of the things that happens soon as you, one of the things that happens soon as you start thinking about decisions is that you start thinking about the characteristics of the decisions themselves. And I think this is actually an incredibly important element of all of this. The idea that we're actually talking about decisions that people make today, not problems and decisions that might be somewhere out in 2070 or 2100. Really, no decision maker is interested in anything which isn't in the sort of time frame of the next few years of activity that they're going to be undertaking. So shifting the focus back, again, talking about impacts, we tend to talk about them in 2030 or in 2070, and it gives us, even though you have to know them again, it gives people a sense that everything's off there in the far distant future. So I think it's actually far better to start from asking people, what are the sorts of decisions that you face today, and which ones of those are going to run into climate change? And you know, this is actually quite informative. If you're choosing your annual crop, you can do it again next year, and then again the year after, and again the year after. You don't actually have to take account of climate change in 2050 to do that, even though crops, of course, are going to be hugely affected by climate. If you're worried about creating a new genotype to plant as a crop, well, then you have to have a 15 or 20-year crop development time frame and marketing time frame. So you start thinking about a 20-year sort of time frame. We should be developing the crops now for 2030, which means they ought to be allowing for higher levels of CO2 and things like that. Of course, if you're thinking about big chunks of infrastructure, then you get longer, and if you're thinking about where suburbs are going, which you don't normally want to move at all, then you're really out on that century sort of time frame. This is important because it immediately says there's all these decisions you actually don't have to worry about. Cognitively, it actually immediately relieves the pressure on people This is probably a bit of slightly over-adapting in this particular instance here, for example. And these are the sorts of things which you don't need to worry about right now. At least that person doesn't need to worry about sea level rise. It also then can focus you down on the particular elements of climate change that you need to worry about for this particular decision. So again, I think people have this cognitive load of everything out there in the climate system being important because we tend to present it as a scenario of all the changes. If you start disaggregating it to decisions, you can start saying, well, this particular decision has to worry about temperature. Perhaps this other one has to worry about sea level rise, and others may have a couple of those things, but it's very rare that you have to worry about all of those things in one go. And that then enables you to start disentangling the issues around uncertainty, which is the next thing I want to tackle. Because there is this immense sense of the enormity of uncertainty just inhibiting everything that we do. There's a couple of issues about that. The first one is that, in fact, as someone again mentioned today, some things really aren't very uncertain at all. I think one of the perverse effects of being fairly confident that we're not going to stay under 1 trillion tonnes of carbon in the atmosphere is that we can be pretty certain we're going to hit 2 degrees of warming sometime mid-century, give or take 10 years or so. And that's about as sure as any bus that you've ever sort of waited for. In fact, probably a lot more certain. Similarly, you can think about things like sea level rise. We know the trajectory of that. Yes, there's a bit of uncertainty about timing, but we're going to see a metre of sea level rise sometime around the end of this century or early next. So we can plan with those sorts of things with a great deal of confidence. And when you start untangling the different sorts of variables there, you know, there's a group of things for which direction and, in fact, approximate magnitude is pretty sure, at least in the medium term, things like temperatures, extreme temperatures, sea level rise, and so on. There are some others where we can be very certain about the direction, even if we're a bit unsure about magnitudes of change, and you can see a list there, and there's others where even the direction is uncertain. But at least those ones where there is really deep uncertainty, which is true for things like regional rainfall regimes quite often, although not in all regions, at least for those ones, at least we can focus down to just those ones and worry about how hard they are to deal with the uncertainty rather than just having this feeling that it's everywhere. And, of course, even on those ones, actually we have right through society millions of ways, of very well-known ways of managing risks. So once we turn it around to being a decision facing a particular sort of risk, we can actually deal with it with a lot more confidence than we sometimes seem to suggest. I like this this paper by Stefan Hallegate, who outlines 5 ways there of reducing the risk of decision making in the face of uncertainty. And they're things which, again, we know really well, but it's handy to just remind ourselves of that. Obviously, selecting no regret strategies that yield benefits even if you don't have climate change. You can have things like reversible options that you might implement, but you can pull back from if you need to. You can buy safety margins, you know, the bigger dam base, but not actually building the full dam until you're sure you need it, but reducing the cost if you do. Having soft options, dealing with water demand rather than supply to start with, and actually reducing decision timeframes. And I want to come and talk a bit more about that. I mean, the technical one is things like having buildings which just last for a shorter period of time, so you've got a new opportunity to revisit the risks of them. And my main point here is not to go through any more detail on that. It's just that there's extremely well-known suites of risk management frameworks and approaches to bring that into decision-making. And we should not fear uncertainty. It should not delay decision-making. So that sort of suggests you can start to be a bit systematic about classifying decision types and the sort of future change that they face, and then consequently the type of risk management you might apply to it. And my point today actually isn't to dwell on this at all. So just to say that you can start to systematise that and think about the appropriate sort of risk management to use for different sorts of problems. And it turns out then that there's only actually a fairly small category of ones which are really awkward and difficult. Of course, there are quite a few important decisions in there, but it's much less than this sense of everything. Okay, and then the other thing is the degree to which you really can break down these decisions into manageable bite-sized chunks. There are some things which it's hard to do that to. I mean, but again, they're the minority of things. So the classic example, of course, is, which I'm sure anyone in the climate adaptation area is knows well is the decision pathways approach to the Thames estuary, a bit of an engineering one. But the idea there that you have a series of alternative options you could take, they have different costs and benefits associated with them, and that looking at them systematically, you can see that what you might need eventually to do in the long term of building a new barrage, a very expensive thing to do, you don't want to do that to begin with. You can plot a path that at the moment is sort of optimal through there, that pale blue line, and you have some decision points in there where you'll stop and reassess whether it remains the sensible thing to do as the sea levels rise. So that's your sort of classic decision pathways idea, and this is just a sort of abstraction of that, which is due to come out in a paper shortly, just thinking about what it's really about. It's this idea that there are multiple pathways going forwards, that you have decision points well defined. It's the sort of thing that engineers and project managers use all the time, so again, it's not a particularly novel thing, but applied in the adaptation space, I think, recognising that there's perhaps areas that are clearly maladaptive, which you want to stay out of, but also decision points where you may change the optimal pathway going out into the future. There's actually quite a lot going on this at the moment, and I just thought I'd throw up a couple more slides just for a couple of other interesting reflections. There's this formalisation of a sort of parsing of these things from this paper by Hasnoot and co. from the Netherlands. They've done some, I'll put this up just to befuddle your eyes, but they've done some much more complex ones of these, still again broadly in more of a engineering sort of area on water supplies and flooding in the Netherlands. But an interesting thing they've done, which is why I just put this up, is they've thought about the social aspects of this and asked if you had different worldviews, you're more of an individualist or more of a communitarian, which are likely to be the routes through this that you favour, and you can start to think about those and start to look for routes where people from multiple different worldviews are most likely to agree. So it starts to be a tool for thinking about how you're likely to get agreement in society, which I think is really interesting. Also, although those are quite engineering sort of oriented in many ways, we've been doing a bit of work recently with remote settlements, Aboriginal settlements in Australia, thinking about some things which are much more, include anyway, some much more social sort of aspects of change, thinking about the balance between dealing with short-term vulnerability and longer-term resilience and things like that. So you can use these in quite imaginative ways, I think. And they take you down the path, actually, as you start to do that, of realising that you can have a slightly more complicated version of this conceptualisation of an adaptation pathway out into the future there, where in actual fact that box sort of surrounds something that looks like what I put up before, but there are some added complexities and intellectualizations you can put around this. You can see that the adaptive space may actually change into the future in possibly somewhat uncertain ways, affected by other actors' activities as well as your own, as well as climate change. There are times when you might need transformative change to get out of trouble, so really substantial and dramatic change rather than following a fairly steady path. That you have to think about things like path dependency. You may come into a decision point having commitments from the past which tend to drive you in a particular direction, which may be maladaptive. And perhaps most important of all, we need to stop and think whether we're actually in an adaptive space in the first place, and I guess that gets to the adaptation deficit that we were talking about earlier on today. But often you need to make quite a significant shift, or at least make sure you're moving incrementally in the right direction strongly in order to get into the adaptive space. So that's enough on that. So that takes me to say, I think that's been trying to articulate this idea that we should be concentrating on the solutions and the decisions rather than being so problem-oriented. Of course, you have to mention what the problem is at some stage, but shouldn't be just ramming that down people's throats. We need to be focused in our discussion with people, with decision makers on the decisions they're taking today, or at least in the near future, and try to get away from giving them this sense that it's all out in 2070. And rather than forever talking about uncertainty, we really should be talking about risk management and the fact that there are plenty of well-known things to do about that. Now, I'm about halfway through my talk, and I figure you're probably half asleep now, so I just wanted to get you to do something to wake you up and talk to the person next door for a minute. Just take 2 minutes and tell me, because this is going to affect where I'm going next, give me one word that characterises to you what adaptation is actually tackling. So just one word. Just have a quick chat with the person next door for a couple of minutes, or say hello to them too. But I need to bring you to order. In fact, the last time I did this, I gave people 3 or 4 minutes. It was actually on a question about future global change and what they should do about it. And after about 2 minutes, there was a couple kissing down the back. I had to say, maybe you're taking the discussion with your neighbour a little far there, and I'm not sure exactly what that's got to do with global change. But anyway, give me a few words. Lifestyle. Cool. Give me a few more. Risk. Behavioural change.
Sustainability, if it's social, economic, and if you have to choose one.
Right, that's good. That's good. That's good. Give me a couple more down the back there. There's various people. Change. Development. Misery. Now we're hitting the real emotional ones. That's good. Resilience. Too resilience. Sorry. Coping. Great. Yep. Survival. That's a good one. Avoidance. All right, that's probably enough to take me into my next issue to discuss. So what I want to talk about now is the fact that we tend to find adaptation framed as an environmental issue in many cases. Now, you may challenge me on that because I know, and this may be something that's a little different between here and Australia, but you know, I look at the Australian. Where does climate change sit in Australia? It's sat for a long time in the Department of Environment, then we created a Department of Climate Change and sundry other things, and then recently it's been just moved back to the Department of Environment, including the adaptation side. Just as an anecdote, we had a talk from someone from the ADB, the Asian Development Bank, just recently, and they were very pleased, and justifiably so, that they'd finally managed to get adapting to climate change firmly embedded in their project assessment process. But it was embedded in the environmental impact statement or assessment. And I had to put my hand up and say, is this actually an impact on the environment? No, it's actually an impact particularly on our social and economic issues. Not on the environment as well, of course. But so this is my next point, that we have to try and reframe this away from being only an environmental issue in decision makers' minds into recognising that it's a very significant social and economic one. So misery and survival, those are the ones we should be thinking about. Because of this. I like this cartoon, which well, I don't really like it. It's just the reality of the world. It's actually a horrible cartoon because it's true. But that's what I want to talk about for a few moments now, and I want to give you a few examples where we've been seeking not to stop worrying about the environmental elements of adaptation, but really trying to frame up the implications of doing adaptation in economic and social terms. So here's one example, and actually we're also trying to frame it in terms of the actual adaptations and the benefits of doing adaptation rather than just the impacts and the risks and the costs, but actually trying to get through from that. So this is an example for Northern Australia, and it deals with, essentially it deals with cyclones. It's a question of whether really this area that's in the circle there, which at the moment is really just about below the cyclone zone and consequently has no cyclone building standards in it. It's whether, in fact, we ought to be worried about that. Now, this is an interesting case. I bring it in because it brings together a few of the other points I've been making too. We don't actually know what cyclones are going to do in this area. Well, we don't have a very confident sense of what the futures for wind will be here. It could be that there'll be no change. That's actually unlikely. As you probably know, the most likely things at the moment are that we get a slight decrease in frequency and an increase in intensity. And there is a possibility that they will move further south in Australia, in fact, on both sides of the continent. So the question is, should we be in fact doing something about this, such as changing the wind loading standards for buildings in that area of Australia today? And it turns out that even with a 7% discount rate for those who care about these things, which is what our Treasury uses to assess its economic returns, it turns out that there's a net present value in making that change. So we actually go down and model the changes to houses every time they come in as a new house, what the impact of the extra cost would be as opposed to the potential benefit in face of a whole series of different future realisations of 100 years of possible climate sequences. And it turns out that there's a net present value, even if there turn out to be no changes in wind extremes, but actually potentially a lot more if we really do get an extreme, if we get a significant change, and particularly with these cyclones moving further south. It shows a couple of other things too here as well. So this is a graph here, and you can see that there's dates across the bottom and relatively large numbers of dollars up the y-axis. And what it shows is the net present value in today's values of making these actions under 4 different scenarios there, which go from no change down the bottom up to the worst case if cyclones actually move south on the top blue line there. And it shows the net present value if you implement this changed policy, which would require a change in our building standards, or our building code technically, if you delayed that 10 years, 20 years, 30 years. And you can see that the benefits drop off quite rapidly. So there's a lot to be said for doing this quite quickly. So this just illustrates, I think, an interesting thing. It is actually a no regrets case, although, you know, that's a fairly unusual and fortuitous thing. But what that says, of course, is that we have the standard set too low for today anyway, probably. It's robust, so it's robust across a whole stack of scenarios. So actually, the uncertainty doesn't really matter. It's definitely worth acting early, and it's also a case, although this is a point I haven't got onto yet, but where some sort of collective action is needed, because we're not going to get the house turnover that's and the changes in standards if there isn't some intervention at a national level. So that's one example there. Here's another one looking more at the social aspects, and you won't be able to read this, so let me interpret it with 3 dots. If you concentrate on those 4 little circles, sorry, 4, I can't count anymore, you'll see that there is a small, this is looking at the impacts of heat waves in actually that same area of Australia, looking at their impacts on this measure of years of life lost across the population. And in fact, the first degree of warming provides a benefit. There's slightly fewer cold deaths in winter, and there's no significant increase in heat deaths in summer, or roughly. As you go across, though, you go to 2 and 3 and 4 degrees, that line sort of vaguely represents what's happening, which is that we get very significant increases. So here's a social measure which strikes to the hearts of politicians who have electorates, which most of them usually do, although we have one who's just bought his way into Parliament, but we won't talk about that. So we can then take this up to another level if we're really trying to engage with policymakers at a national level and start thinking not just regionally like that, but actually how does this play out at a national level if you actually try and model some of these things sort of local area by local area, but accumulated up to the nation, and do it not just for one hazard, but start thinking across a whole series of hazards. And I'm working towards a theme here. And when we've started doing this, and I'll give you a couple of initial results, but this is something which is in progress right now. But you can see we've started to develop these hazard maps across the continent. We've started doing it for inundation, coastal inundation as well, and actually starting to model those out into the future, which of course you need to be able to look at this. You can couple that sort of information with the infrastructure databases, which Geosciences Australia holds in our case. So there's all the building infrastructure, but there's also other sorts of infrastructure like networks, various networks, road networks and energy networks. And it turns out, first of all, we have to think about this in terms of not only climate, but other activities, of course. So there's population change, economic change. And if you start projecting that into the future, just looking initially at exposure, but we need, of course, to get beyond that, just to give you a sense of the magnitude of the problem here, you can see that today something like 10% of our, this is our residential and commercial building infrastructure, is potentially exposed to one of the effects of inland flooding, coastal inundation, or fire. A lot of that's due to fire exposure, in fact. You can see that increases. You can see that the right-hand columns of each of these pairs is the actual total value of infrastructure. Projecting that forward on our median sort of population increase and thinking about its distribution and various bits of good analysis like that show that the total value, of course, goes up massively by the end of the century, but actually the proportion of that value that's likely to be exposed goes up to 15% or so. Yes, that's right. Which means that by the end of the century, we've potentially got nearly as much buildings exposed if we did no adaptation at all, which is very unrealistic. But we would have nearly as much infrastructure exposed as our total infrastructure value today. So the question then is, well, what about doing something about that? Of course, because something will happen at least. And there's a variety of sorts of ways that you can think about this. So this is just reporting some initial results on at that scale then, with local resolution, looking at the effects of basically a sort of backward-looking current policy sort of thing, repairing to our current standards when you face one of these hazards, reacting in a backward-looking way. So this is reactive, but nonetheless including all the information up to that date. So if we're looking at 2050, obviously we will then have a lot more knowledge about what's actually happened, as opposed to being anticipatory. So saying, actually, this infrastructure's got a 50-year lifetime, we should be planning for maybe 40 years into its future at least, and taking the best estimate of the likely risk at that point. And it turns out, in these preliminary results anyway, which appear to have vanished on that, here we go. Oh no. It turns out that you get some significant improvements in the sort of, again, discounted present value of impacts here. The numbers don't look terribly big, but they are actually only one subset of the infrastructure, but looked at nationally. But more importantly, from the economic point of view, it turns out that we are looking at potential returns on investment of possibly as much as 20 to 1 in a net present value sense. So this is a really significant potential benefit to the nation. So again, trying to put this into the language that decision makers are using is a really important thing, and that's really the point of this, trying to move from being framed as an environmental issue to being framed as, or only as an environmental issue, to being framed as a social and economic one primarily. The last theme I want to address here is really whose responsibility this is, and how do you engage with national governments to recognise that something's important. And the bottom line is, I mean, I think we tend to think that if there's a big impact, then government ought to be worrying about it, and that's actually quite wrong. This, or something vaguely like this, really ought to be the decision process that a policymaker goes through. Is there an impact worth worrying about? Well, we've shown that. Are there adaptation options available? And in fact, are they worth implementing in terms of return on investment? Well, we've shown that potentially, but that still doesn't mean that it's necessarily government's role. We actually have to be able to actually show why it matters for government to actually do this, rather than just leave it to the free market, or maybe just make some minor modifications in policy but not really take it very seriously. So this takes us to thinking about a whole stack of emergent implications, I think. I mean, there are things which governments should do directly anyway because it's their own property or whatever, but there's a stack of other arguments which I think we haven't been articulating very well, and Guy Midgley's taken a few of mentioned a few of these today, but let me just reinforce them. So these are going to be entirely Australian examples, but here's a few examples of why we might want to think a bit differently about this. These are the Queensland floods that we had in 2 successive years. Closed a lot of, you can see an airport closed there, central Brisbane underwater, a lot of value there. But actually, the two most significant ones in some ways are the bottom two, because the airport wasn't closed for very long. But you can see on the bottom left a very significant impact on the energy network, and on the bottom right you can see the railway flooded. That railway is actually one of the export railways for our mines, so flooding that wasn't just a minor inconvenience for people travelling on the rail. It actually interrupted a massive amount of export for several weeks. And to take that a step further, here's what happened in some of the mines in that event and others. So we're increasingly seeing examples of this, cases where mining is interrupted and the mining company loses a stack of money, but actually the federal government loses a load of money out of its tax revenues and things like that too. So we're starting to see emergent effects there. Why should government worry a bit about this? Well, it's fairly clear, at least in Australia, that the mining industry is lagging well behind things like local government and even mining industry in other parts of the world in thinking seriously about that, and there's some survey results about it. Other sorts of events, I mean, you can think of this in all sorts of places. In 2009, we had a very severe southeastern Australian heat wave for several days. It was just before we then had a whole load of bushfires. But actually, the heat waves were in some ways more interesting. I don't mean that in a nasty way to the people who lost their houses in the bushfires, but the heat waves actually also caused a lot of premature deaths. Actually, quite a few more than the bushfires. But we had these systemic effects that you can see listed down there. So it wasn't just that we had some premature deaths, that was bad enough, but there were power blackouts, and those things flowed on to a whole stack of business failing to operate. We had transport disruptions where trains just couldn't cope with the temperature. We had a whole lot of flow-on effects. There was a whole stack of horticultural activities in the region immediately around Melbourne, which lost a whole lot of crops. So all the whole system started to go down, and it was far more significant than just adding up the individual impacts. There was this overall economic impact of well over $1 billion to the economy. So the question is anyone managing these emergent risks? Because this probably should be the role of government to think very seriously about these. So just to recap on these, there are supply chain sort of issues. As you can see there, a large amount of primary energy is actually used in water supply systems. So when you talk to the water utilities in Australia, they'll say, oh, we've got 3 major issues. Of course, we've got a water supply thing, but that's what we normally manage, and we're actually not too bad about thinking long term about those sorts of things. But the second thing we've got is, in the case of Sydney Water, we've got $30 billion worth of infrastructure of pipes and stuff like that that's all getting old in Sydney. And that's starting to be affected by all sorts of things, bits of flooding, bits of seawater intrusion, all sorts of other things. Our biggest worry is that we're going to come to about 2030 and suddenly find a whole lot of this failing simultaneously. And then thirdly, there's this issue that actually we depend on the electricity utilities and we can't control what they do. So we might do everything right, but we'll be stuffed by them. And that actually happened during the Brisbane floods when the power went out and they couldn't pump clean water into Brisbane for a day, and there was a major issue around that. So supply chains, really important issue. I've already mentioned mining and its potential impact on that. The second one is scheduling issues in mobilising capital investments. I've already mentioned the Sydney Water situation, where their big worry is that they're being forced to try and keep water prices down now, but what happens come 2030 if these assets all simultaneously get into trouble? And a good example of that in the public domain in Australia is roads. So in things like the Queensland floods, 82% I think of the recovery money, which was rather a lot, and we're still paying it off on our taxes. But in fact it was something like $6 billion, but we're still going on that from that one event. Something like 80% of that's going to road reconstruction. So this is a really important thing. And that little plot down on the right there shows, for a number of different states of Australia, 3 dates of road length that's exposed to sea level rise. And you can see that in most cases, there's one exception for some reason, but in most cases there's a small rise between today and the middle column, which is 2050, and then there's a big rise out to the end of the century. Now, when you think about it, it's not surprising. These are roads built to a certain standard. They're a certain level above normal tidal risks and so on. And at some point, they'll start getting flooded. Most of these roads are owned by individual local government. A few of them aren't, but most of them are. And so they are likely to go ahead and think about assessing each project by project. And probably for that, that'll say that around about 2030 or 2040, whatever the maintenance schedule time around then is, they should upgrade it to allow for climate change. If they all do that at once, there's going to be thousands of kilometres of road in our road system that in 1 decade suddenly needs upgrading. But of course it's worse than that. It won't just be that, it'll be the same for a whole stack of other infrastructure and so on. So there are these massive emergent risks on the economy which are simply not accounted for in some of our economic models. Guy, we were talking about this earlier. And I think the last thing I was going to mention here is just the issue of coincident events. So I don't think we're on top of this at all. Events which happen in the same place multiple times within one, quite soon after each other. We started seeing that in Queensland. Things happening at the same time in different parts of the continent. So we had fires in southeastern Australia at the same time as flooding happening up in Queensland. Started to really stress our total national ability to respond to emergency events. And then things which are just happening within one budget cycle, which basically overload the budget. And all of these things, by the way, I mean, I've put this in terms of a national issue, but you can push all of these things up to an international level too, and I think this is another thing we need to be thinking about. So, for example, bushfires in Australia this year have started not completely abnormally early. It has started this early before, but it's pretty unusual to get as big a fire as we have. And it's actually overlapping with the end of California's fire season. Now that's actually a global problem like this, because we send a lot of equipment to California when they're having fires. I don't know whether we send it or whether you guys probably do too. But if we start seeing the fire seasons overlap, of course, then suddenly we've got a global issue of needing to multiply up the total emergency gear on the globe we need to sort of think seriously about doubling it so that both hemispheres can be thinking about these things at the same time. So these are really significant emergent sort of effects which we really have not got to grips with in terms of our messaging and talking to government. And I think oops, I just went the wrong way. And it relates, so this relates to this, I think, characterization of adaptation as being largely a local issue with a little bit of sort of guidance from policymakers. I think that's actually an incorrect framing. You can think of adaptation actions, not just policy framing issues, but actual adaptation actions at all levels, right up to the international. And I think it's better to think of it a bit more like this, that there's adaptation actions happening at all levels. There's also sort of policy context-setting actions which affect players at other levels happening at all levels. And there probably is a bit of a tendency for there to be more of the context-setting stuff higher up, but there's actually things adaptation-wise that need to be thought about all the way up there. And so there is a real responsibility to be talked through with government about that. So coming back to my overall adaptation message then here, there's my 5 things which I think it would be great if we could get much more on message about, that we're actually talking about solutions, not about problems, or we're thinking about the decisions. Of course there's a problem behind it, but that's not the first focus if we're trying to get adaptation thinking going. We're talking about those decisions today, not way out in the future. We're talking more about risk management than just being lost in uncertainty. We're really trying to reframe this as a social and economic issue, not just a environmental one, and that we think a lot more about these emergent challenges, not just the local expectation of dumping everything on people locally or firms locally. And I think coming through that, you actually find it enables you to think much more about systematic planning processes, which we've heard a bit of today, and there's a lot going on, but still at times swamped by some of this broader rhetoric. It makes some of the mental models more manageable, and it also starts to articulate where some of those responsibilities are. So there was a point today about local government municipalities here wanting more guidance from the national level as to what they should do. Exactly the same problem in Australia. And I think then all of this has a flow back to the sorts of adaptation challenge that Karen was talking about earlier, because it starts to highlight where we can deal with these things and where we can't. Now, Mark, I have a question for you. I have used my time. I have got 3 minutes of slides on Future Earth if you'd like me to slip them in as a segue to this, or I'll stop. Put them in? All right, if people can bear with it, then I just wanted to take this because the same issues, I think, almost exactly the same issues, play out at a global level across a much wider field than climate change alone. And this relates to a developing approach at the global level called Future Earth, which I just want to mention very, very briefly. So we have this changing global environment for science. I think people will have heard about the Anthropocene, the idea that we really have to start thinking about ourselves being responsible for planetary stewardship now. We can't leave it to someone else and hope to nick off to another planet. This also is coming on us with increasing urgency. But many of the sorts of things that I've just been talking about apply here too. This is not just an environmental issue of people moaning about too much nitrogen in the world or something like that. It really is something that flows through to social and economic instability and all the other things that I just mentioned. This particular thing, just to talk process for a moment, has emerged from a suite of global environmental change projects which have gone on for some years, and they've got horrible acronyms. I don't think I'll spend time. Oops, and that one's gone. In fact, it doesn't want to spend time on them either. Things that have dealt with analysing the World Climate Side, World Climate Research Programme, which has been around since the 80s. A thing which has got the worst acronym of any programme that I've ever come across and I was closely associated with, which is the International Geosphere Biosphere Programme, dealing with a whole raft of other biophysical sort of issues. Diversitas dealing with biodiversity, and the International Human Dimensions Programme, which dealt with more the human aspects. So these are global research coordinating programmes that have been going for quite a while, which have been brought together this year really, or it's really getting going this year, in this thing called Future Earth. And Future Earth aims really quite actively to provide knowledge that's really required by decision makers in society to help the globe face the sorts of risks that we know it faces and that we weren't facing terribly well at Warsaw last week. And in addition, I should say, very much to seize opportunities in thinking about a transition to global sustainability, which creates all sorts of opportunities for us as well as avoided hazards. Future Earth is seeking to pursue three broad areas of research. One, down on the bottom right there, really trying to understand our dynamic planet, and then two others which deal with how global environmental change interacts with development globally, and then most importantly at the top, how we think about these transformations towards sustainability, particularly at that more global level, and there's a number of cross-cutting things. The effort, the Future Earth, aims to really live some characteristics. It aims to really think about being solutions-oriented, the same thing I've been going on about. It aims to really engage well with decision makers in design and production of knowledge and exploring it and various other things, with decision makers on the global scale, but at the national and regional level also. Its focus, its niche, is in complex questions that really can only be answered with international collaboration, operating from that regional to global scale, and trying to become much more integrative in terms of the disciplines that are drawn upon. Here's a southern view on the globe, one that includes both South Africa just about and Australia, of course, centre stage. But just emphasising that there's a real process of building networks going on at the moment, and I hope that those of you who might be interested in just this very, very quick mention of Future Earth would get involved in that. But with that, let me leave you to it, and I hope some of that framing resonates usefully.